Hey, this is Mrs. V here. Here's our lecture on feedback mechanism. And we're going to talk a lot about hormones in the endocrine system. But really we're going to talk about feedback mechanisms as we talked about transport last time. We're going to talk about how transport is pretty important inside our body. So if you haven't already, go ahead and go to Google Classroom. Make sure that you have open up your notes here, feedback mechanisms, so that you can start typing. Okay. All right, so let's go ahead and get started. If I can get my programs to work for me. Okay. So we have feedback mechanisms in the endocrine system. So our essential question today is, how do negative and positive feedback loops help our cells perform homeostasis? So make sure that you are writing down your central question, and our central question today is, how do negative and positive feedback loops help our cells perform what we call homeostasis? So homeostasis just means that we keep it the same. It's kind of like an isotonic solution, right? That we keep it the same temperature, we keep everything the same level, same amount of oxygen, same amount of carbon dioxide in our blood or in our cells. Okay, so we're going to talk a lot about what we call our endocrine system. You don't have to know that this is our endocrine system. This is a background as I'm trying to get you to understand a little bit of what I'm talking about. So the endocrine system is a control system of ductless glands that secrete chemical messengers called hormones. So our hormones, you probably heard about them, all your hormones that kind of move through, but our hormones tell us to do certain things. And they circulate through our bloods, and they affect our organs, okay? So they are the messengers. Some of the ones, I'm not going to read all this, that we may have is salivary glands or our exocrine glands. So salivary, like they give your saliva. We have sweat glands on our skin and gastrointestinal tract. So you don't really need to know everything about this. It's just kind of give you a background. What is a feedback mechanism? A feedback is generally information about actions, okay? So it tells you what to do. Does it tell you to stop or go? Does it tell you to make it low or high? So we have two different kinds. We have positive and negative. So the human body uses positive and negative feedback in order to keep it at homeostasis, or the level we want. So we want a certain percentage of oxygen in our blood and in our cells. We want a certain amount of glucose. We want a certain amount of lipids, certain amount of carbohydrates, all of that, okay? Positive and negative have nothing to do with consequences. It's not a positive or a negative consequence. You'll see why we named it positive or negative. So the negative feedback loop tends to slow down a process, while the positive feedback tends to speed it up. So do we need more or do we need less? It's not about good and bad. It's just about what we need more of or less of, okay? So useful vocabulary, which you should have in your vocabulary anyways, is we have a negative feedback is a stopping synthesis of an enzyme, maybe is an example, by accumulation of the products of the enzyme. So we have too many products of the reaction, and so we're going to stop making those enzymes, okay? Negative feedback loop is biochemical pathway where the products of the reaction inhibit the production of the enzyme that control their formation. We're going to stop it. If we had a positive feedback, we would increase the production of enzyme, okay? Because we need more. Negative feedback loops help maintain homeostasis, okay? So example of a negative feedback. So you might have, here's our hormone going way up, and we need it to go up to make it, but once we get it, then we want to go back down, and that's when the production of our hormone also goes down. So what if you get too cold or too hot? Well, you start to sweat, right? So if we have here, so we have an imbalance, right? Homeostasis is imbalance. We're way too hot. So then we go this arrow, blood warmer than we would like. It reads in our brains. It goes to our blood vessels, which makes it bigger, and it makes us into our sweat glands say, hey, 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 you're way too hot. So then what happens is you start sweating, it starts cooling you off, and that's when your body temperature goes back down, and now we're back at homeostasis, okay? How about if we're way too cold? Maybe we're way too cold. That goes to our brain. It constricts those blood vessels to keep that heat. We're not sweating, but you also may shiver, right? You get that shivers with your muscles, which makes heat to increase that temperature, and we're back at homeostasis. Okay, so here's something. Is this a negative or a positive? Well, here, right, we want bigger things. So we can call this possibly if we want bigger vessels, the vessels are going to get bigger. We want more vessels, so we want more stuff. So we're going to go with a positive, and here we're going to get smaller. That would be your negative. Okay. Here's an example of a feedback loop. Okay. So let's say that the teacher is willing to try new things. Okay. So then it goes to the technologist, which helps give you new lesson ideas. The teachers recognize the value of this one. Goes to the school administration, like the principal, Mr. Sarkeesian. He says, ooh, that looks good. So then he gives it to the main district, the big ones, who then put it out to all the teachers, and then this loop happens again. Okay. Is this a positive or negative? So we have one teacher trying it, and it goes through, and more teachers try it. So answer for yourself, positive or negative. What if another example is your blood sugar? So your blood sugar is controlled by your actual liver. So let's look. So here's our homeostasis, and we're at homeostasis, say, and we're good, and we're happy. We're at homeostasis, and nothing happens. But what happens if your blood sugar goes way too high? Well, if it goes too high, okay, this is our stimulus. Our blood sugar goes way too high. So then part of our cells of our pancreas start making a hormone called insulin, and they start releasing that into the blood. So now you have insulin, okay? That insulin causes the cells to start taking up glucose out of the blood, so that we're lowering the blood's concentration of glucose, or of that solute, that glucose. It can also cause the liver takes up glucose and stores it as well, and it stores it as something called glycogen. But because our blood sugar was way too high, started making insulin, that insulin starts being able to push things into storage to take it out of the blood. And because of that, our blood sugar lowers back to where the level we like it, and we enter in homeostasis again. Okay. This right here, if you have anyone that has type 1 diabetes, this is where the problem occurs, is where their blood sugar goes too high and actually insulin isn't produced and they can't lower it. So that is what they actually inject into their body, is a man-made insulin to get this glucose to go down. So and if you have too high of a glucose, it can cause a lot of problems. How about if it goes too low? This can also happen in diabetics. So if we have a too low, that's our stimulus. Basically, we need to get more glucose into the system, okay? So it's too low. We need to make more glucose. So it goes to our pancreas again. It says, oh my gosh, all those storage that we stored up here, we need to start getting rid of it. So it starts releasing glucagon, and which is glucose, can be broken down into glucose in the body, releases it to increase our blood glucose level, and then we're back at homeostasis. So this right here, we have a high. We need to decrease the amount of glucose, so it actually is a negative feedback. This one here is we need to increase. We need to make more glucose, so this would be our positive. Okay. Another feedback loop. So another one is in breastfeeding, and we have the stimulus of an infant suckling. It goes to our brain to say, oh, you need to release the milk. That baby is very hungry, which actually goes to another part of our brain. It lets the milk out, goes into the breast cells, and then when the infant stops, stops drinking, it actually goes back up to your brain to shut it down. So this is a positive and a positive feedback to increase milk production. Okay. Is bone homeostasis positive or negative feedback? So here's another example. So here's our calcium. We have calcium in our blood. We like it at a certain level. What happens when the calcium goes too high? It goes up to our thyroid glands, which is up in our brain. It releases what we call calcitonin, and calcitonin stimulates calcium salt. So it takes the calcium out of our blood, deposits in our bones, which then decreases our calcium. So again, we're decreasing. So in the end, I want you guys to think, is it negative or positive? This one, calcium is too low, so then it goes again to our thyroid gland in our brain. This time it starts releasing what we call a hormone called PTH, and this is when it starts breaking down bone calcium to release that back in. So think about, how about this first one? Is this first one positive or negative? Calcitonin, is it positive or negative? Remember, decrease the amount of calcium. And is PTH positive or negative? Okay. All right, so those are our notes. So what I want you to do now is, again, to go back and reflect on your notes, highlight or underline, make connections to your notes in the left column, use all that to write a 3 to 5 sentence summary on these, use your connections, and then submit your completed notes to Google Classroom assignment. Once you have done that, then you can go ahead and work on your homework for tonight. So your homework for tonight is going to be this homeostasis worksheet, which is right here. So you click on that. You can open this up. It should give you your own worksheet that you can go ahead and edit. And you're going to read a couple of different scenarios and tell me if it's a positive or negative feedback. Remember, positive means you make more of something. Negative means you make less, okay? So if blood temperature rises too high, specialized neurons in the hypothalamus of the brain, don't worry about all the fancy words, sense the change. So your blood temperature goes too high. These neurons signal other nerve centers, which in turn send signals to the blood vessels of the skin. As these blood vessels dilate, more blood flows closely to the body surface and excess heat radiates from the body. So the heat is leaving. We're decreasing the temperature. Would this be positive or negative? And all you need to do is go ahead and click in here and tell me if it's negative or positive. So I'll give you this first one. We're decreasing the temperature of our body. So this is a negative feedback. It would usually type it feedback. Okay, so that's all you need to write in all these. So you're going to go through all of these different scenarios. There's only 6 of them, 1 page. Well, 5 of them. And then in the last one, number 6, you're going to choose what it is. Okay, A, B, C, or D, and write that in the box. Okay, again, if you guys have any questions, please let me know. I am more than happy to help you. Have a great day.